Okay. So in this list are shown 25 names of 25 students. So with this problem, I was very easy integrating just because it's such an opinion in a way if it's a boy's name or a girl's name. So on number um 32, we're gonna circulate a little back. But this list shows the names of 25 students at a contest to win a free diner at a local restaurant. There are the 25 names. The total number of names, as it says on the problem, is 25. So some of these points were just for you to get it, like free credit kind of. Now, find each probability. Write it as a fraction, decimal, and percent. So you're going to only find one probability. It's just represented in three different ways. So probability of a name that starts with M. There is one. Let me highlight that. There is one with M. There is two with M. Three, four. So there is four names with M. So as a fraction, I know that every probability is the desired outcomes over the total amount of outcomes. So it's 4 over 25. As a fraction, as a decimal, we need to divide the numerator by the denominator. So 4 divided by 25, which is 0.16. And as a percent, all we got to do is take this decimal and multiply by 100. By multiplying by 100, the decimal point moves to the right. The decimal point moves if you multiply or divide by 10, 100, 1000, etc. So a power of 10. As many zeros as you have, if you multiply, it will move to the left. If you divide, if you multiply, it will move to the right. If you divide, it will move to the left as many digits as it has zeros. So since we are multiplying by 100, this decimal point will move to the right 2 digits. So as a percent is 16%, and you have to put the percent there in order to know, because 16 is a number and it's not equal to 0.16. While 16% is equal to 0.16. Now, the names that starts with a J. I don't see any. In my list, there is no names that starts with J. There was a couple of lists that there were, but if you don't have any, the number is 0 over 25 as a fraction. You have to write it that way. It is 0.0 as a decimal, and it is 0%. A girl's name. So some that I considered correct here were that used 25 out of 25 because and wrote their rationale as there is no boys or girls name, which I do respect and appreciate that. And I did take that as correct as long as you put them as a fraction and a decimal and a percent correctly. So if you said 100 over 100, 25 over 25, and as a decimal you wrote 1.0, and as a percent you wrote 100%, then that is also correct. Now let's look. Bob, Paul, maybe Jaisley could be a girl's name. Let's put it in purple. Let's say Shannon. Let's do Holly. Let's say Larissa is a girl. Aya is a girl. Renee is a girl. Chris could be a girl's name. Danny could be a girl's name. Eliza, I'm gonna go with the ones that I might be certain. Vicky, that might be girls' names. So 1, 2, 3, 4, 5, 6, 7, 8, Gary. Well, I'm sorry, I forgot because the girl's name in yellow, because Mora could also be a girl's name, right? And Mary is also a girl's name. So are about 9 of these names out of 25 are girls. 9 divided by 25 gives me 0.36. And as a percent, that is 36%. Kind of similar with 33, 34, 35, but instead of names, we're flipping coins. Danny and Paul decided to flip a coin 10 times to determine who gets the last slice of pizza. Danny chooses heads, Paul chooses tails. After 10 coin flips, here are the results. So I'm gonna highlight the head in orange. There's one head, 1, 2 tails, the second heads, 3, 4 tails, a third heads, 4, 5 tails, a fourth head, 6 tails, but a total of 10 flips. Now, the probability of getting heads, we have 1, 2, 3, 4 out of total 10, which is 4 divided by 10 as a decimal is 0.4 times 100, that is 40%. Tails, we have the remainder, which is 6 over 10. So if I had an answer 4 or 6, you know that I will and I have considered that incorrect because 6 is a whole number. It's not a fraction, it's not a decimal, it's not a percent. 0.6 times 100 is 60%. So I know that Danny chose heads and Paul chose tails. So Paul has a higher chance, which is 60%, therefore he will get the pizza.